Hello my dear warriors, welcome aboard to the Fasttrack series on your favorite JEE English channel, and this is Captain Shreyas here, your physics master teacher, nurturing and sending kids to the top-notch institutes of our country. So stay tuned for many more amazing classes on the channel, and you can definitely follow me on my Instagram handle to know more about me. So guys, this Fasttrack session is all about quickly going through all the concepts of all the important high weightage chapters for all competitive exams in a very precise and concise manner so that you can revise all these topics very quickly and save a lot of time. That's why the name Fasttrack series. Also, do not forget to smash the like button because this series takes a lot of time to record, and it also helps me and motivates me to record more such amazing sessions for all of you. Also, apart from these sessions, there will be problem solving sessions on these topics which you can definitely find in the channel's playlist. So let's begin. If I ask you how is your mood, then you'll be like, I'm happy or I'm sad, but nobody will say, sir, I'm happy 70 or my sadness is 20 or I'm excited to a level of 40. It doesn't make sense. So there are some quantities which can be measured, some can't. Those quantities which can be measured, they are called as physical quantities. Like length, volume, density, they are all physical quantities because you can measure them. Happiness, sadness, excited, no, you cannot measure it. So they are not physical quantities. These physical quantities can be divided further into two categories. One is basically fundamental, second is basically derived. Before going there, whenever you visit a doctor, have you ever thought whether fever is a physical quantity? Well, actually fever is not a physical quantity because you cannot measure it. It's a temperature which can be measured. That is a physical quantity. Now this temperature, is it one of those two categories which I was just talking about? Well, what are those two categories? One is called fundamental, the other one is called derived, and they are exactly what they sound like. Fundamental means very basic, elementary. Derived means it's dependent on these quantities. Fundamental quantities can be things like length or maybe even mass. Derived quantities would be things like acceleration, force, which are dependent on these measurements. The best example is right up on your screen. These are the universally accepted fundamental quantities: length, mass, time, current. I'm pretty sure you have heard of these things in lower grades. In the days to come, maybe in 11th or maybe you are already in 12th or taking a drop, you will also hear these quantities like amount, temperature, and the luminous intensity. These are fundamental, most basic. Anything else will be dependent on one or more of these. Like volume is the cube of length, or speed is distance by time. Distance is length, time is over here. So these things are basically your dependent or derived quantities. Now that you know about the two categories of physical quantities, fundamental and derived, each of these quantities needs to be measured in terms of something, and they are called units. Long time back, people used to have crazy units and they were not consistent, they were not reliable. Like if I tell you the distance from here to there is 10 feet, not that feet which you use in British foot-pound system, but just the feet of a person, the person might grow in size. Or what if the person dies, then what do you do now? So something which is reproducible, something which is consistent, something which does not change with time, and something which can be easily made, that defines a unit. So if I tell you the length of an object from here to here is, let's say, 200 centimeters, this 200 is nothing but your magnitude and this centimeter is nothing but your unit. So any physical quantity will always have a magnitude and it will also have a unit. Unit is standard, it's universally accepted. You know what a centimeter is. So it is 200 times 1 centimeter. 1 centimeter will not change whether you look at it after 200 years or 100 years or from some other planet. It is a known standard value. So when I say 100 seconds, it is 100 times 1 second. 1 second is very precise. Nobody can negotiate that. Now, there is a problem because there are so many ways of defining a unit. Each person might choose different units. Now, just imagine somebody had to measure force, which is mass into acceleration. Mass can be measured in kg, grams, pounds, so many other units. Similarly, change in velocity can be also measured in so many units, and time can be measured in seconds, hours, minutes. So if you do all the combinations, permutations, there are crazy number of units in which you can measure force, like kg, meters per second per minute, or maybe gram, centimeter per second per hour. Crazy, right? So it creates a lot of confusion. So that's why you have a system of units. System of units is a very widely followed practice. But of course, there are other standard practices also which are used in different parts of the world. But the main three unit systems which are used are MKS, CGS and FPS. It's exactly what it sounds like. M stands for meter, K for kilogram, S for second. This is centimeter for length, grams for mass, seconds for time. This is foot for length, pounds for mass, seconds for length. So these are the three widely used units. Later on, when it was understood that there are more fundamental quantities apart from mass, length and time, like for temperature or for luminous intensity or for amount of substance or for current, more things were added into MKS, and that became the SI system of units. So kilogram, then you have meters, and then you have seconds, amperes, Kelvin and candela, which is CD, which are basically the units in which all the fundamental entities are actually measured. That is called as SI units, which is an extension of MKS units. Now there is another aspect called as dimension. So one aspect is units, another is dimension. A physical quantity can have multiple units, like length can be measured in meters, it can be also measured in centimeters, it can be measured in millimeters also. But length has one unique dimension. Acceleration has unique dimension but multiple units. So what is this dimension? It's nothing but the power to which the fundamental units must be raised to get that derived quantity. Better explained like this. Imagine volume. Volume is nothing but length cube. Length into breadth into height. So the dimensional formula for volume is this fundamental quantity called length raised to 3. So I'm raising the fundamental quantity to a power. That's your dimensional formula. Same way for density, which is mass by volume. I know volume is nothing but length cube. Usually you do not put all those fundamental quantities in the denominator, you always bring it up. So it is basically mass, raise it to power 1, always raise the powers, into, because you are bringing the length on the top, you will make it power of -3. So mass raised to 1, length raised to -3 is the dimensional formula of density. Now since it's very tedious to write this whole words mass, length, etc., there are short forms for it. So mass, you write it as capital M, length capital L, time T, current amperes, temperature Kelvin, K, amount mole, and luminous intensity CD. These are the standard short forms for instead of writing mass or the entire word length and so on and so forth. So in this case, the dimensional formula for volume, by the way, dimensions are always put in square brackets, standard practice. So the dimensional formula for volume will be length cube. Dimensional formula for density will be m raised to 1 and length is raised to -3. That's how dimensions are written. Fundamental quantities raised to the powers. That's what it is. Now that you know about dimensions, are they any useful? Well, the answer is yes. Number one, it's always used to eliminate options many times in objective exams. Like if you see on the LHS, there is something like length, and on the RHS, it's maybe acceleration. You know that option can't be true. If it's oranges here, it should be oranges there. So this is called as the principle of homogeneity, which says that whatever is there on the LHS dimensionally should be there dimensionally on the RHS. If something is dimensionally wrong, physics wise, maths wise, it is wrong. There is no doubt about it. Best example, take this, S is ut plus half AD square. S is distance, length, dimension of L. U into T, speed, which is length by time, into time will be, time cancels, will be length again. AT square, half is a number, don't worry about it. So acceleration is meters per second square, so length by time square, into T square cancels, length again. So you can see S is also length, UT is also length, AT square is also length, length plus length can be added. Length plus mass can't be added. Dimensional inconsistency. So it has to be consistent whenever you add or subtract. That's the first application. Second application is you can use this dimensional consistency to also derive, an expression for an unknown physical quantity or a formula basically. So when you know that, okay, density might depend on force and velocity and maybe something else, I don't know what's the exact formula. You can guess that formula using this principle and using, dimensional consistency. There is no formula or there is no theory for it. In fact, that has to be done via problems. I'll be taking the problems in the fast track problem solving session. So please watch that. Okay, but you should know that that is the second application of dimensional formulas. The third one is to convert from one unit to other unit. So everybody knows you can convert from newtons to CGS unit or meters to kilometers. So when you do that, what is exactly happening? We know that when we have any physical quantity has basically some magnitude and it has some unit. So if the magnitude is written by a symbol n, unit is written by a symbol u. When we convert from one unit to the other, the quantity remains the same. When I say 1 meter is 100 centimeter, does not mean the length is more in centimeters. Length is length only. It is same. It's just that the number has changed, the magnitude has changed because the unit has changed. So basically the quantity never changes. So n into u, the product is constant. So n1 u1 is n2 u2. For example, 1 meter is 100 centimeter. You can see u is the unit, n is the number. Similarly, I can also write 1 newton is 10 to the power 5 dynes. Dynes is the CGS unit of force. So it can be used for converting from one system to other system or from one unit to the other unit. N1 U1 is equal to N2 U2. Now comes the next aspect, and that is significant figures. Very important while calculations. You should know which of the digits are important, which digits are not important. So that's the meaning of significant. Significant means important. So whenever a number is given to you, there are some digits which are important. You can ignore the other digits or they do not matter in the calculation. For example, there are rules for calculating how many significant figures are there. So I have kept some examples. Let's see these rules one by one. Number one rule is that every non-zero digit has to be counted. Like over here, 7 and 9, 2, 9, 3, here 2. Powers of 10, never count them. Here, there are two non-zero numbers or digits, so two significant figures. 3 non-zero digits, so 3 significant figures. Here only one non-zero digit, so 1 significant figure. The zeros on the right side are not to be counted. Please understand that. Okay, because 7900, I can also write it as 79 into 10 to the power 2. So then it still has two significant figures. Okay, rule number 2, zeros in between non-zero numbers or digits are to be counted. Like over here, 1, 1, 1 non-zero numbers. This 0 is in between them, so count that, so it is 4. Here 1, 2, 3, 4. Again, these zeros are in between two non-zero numbers. Here, two non-zero numbers, one zero number in between of them, so 3 significant figures. Next up, the leftmost zeros which are there are never to be counted, just like the right zeros over there. So left zeros, like the Bond's famous number is 007. Although James Bond might write it, these zeros are not significant. There is only one significant figure here. These zeros are also not significant. There is only one significant figure here. Cool. Rule number 4. If there is a 0 after the decimal, no matter how, it has to be counted. Because you have taken an effort to put that decimal and put that 0. That means there is some accuracy, there is some certainty to it. Or else you wouldn't have put decimal dot 0. So 8, 4 non-zeros, always count them. Decimal 0, so that has to be counted, so 3 significant figures. 1.00, both the zeros to be counted, so 3 significant figures. 2.0, both the 0 and the 2 are significant, so 2 significant figures. So these are the basic rules to count the significant figures. Now you should also know something to round off. Yep, rounding off numbers. You cannot do it randomly. There are some simple rules for that. Let's have a look at the 3 basic rules. First thing you found out for significant figures now is rounding off. Let's say, for example, these are the numbers to be rounded. Always check the last or the smallest place. In these cases, the smallest places are 9, 4, 5 and 5. Now, if the smallest place is less than 5, like in this case, you can see 4. 9 is bigger than 5, this is equal to 5. Then what you do is, basically the previous digit, leave it untouched. Leave it untouched. So this will be approximately 23.4. That's it. Don't touch the previous digit. Don't do anything to it. If the digit is more than 5, like in this case, then it is approximately, what you should do is increase the previous digit by 1. So 6, you add 1 to it, it will become 77. So it is just 77. Fair and simple. If it is less than 5, then just forget about it. Just keep the previous one as it is. If it is more than 5, the previous one increase it by 1. If it is equal to 5, then the previous digit has to be made even. Like if I want to get rid of this 5, this will be approximately 38. Because 7 is an odd number, make it even. Because I have two options, 37 or 38. 38 is even. 58.5, two options, 58 or 59. Obviously 58, that's even number. So make it even, guys. Make it even, because 37.5 is equally close to 37 also and 38 also. Always choose the even option. That's the rule for rounding off. Now the next thing is, what do you do when you have to add or subtract numbers? You cannot just add randomly and leave it. There are rules for that too. Maybe many of you did not know that. So for example, 12.0 and 5.04, whenever you have to add or subtract, always choose the least of the decimal places. Always decimal places. So if you notice over here, there is one decimal place, 0.0, and there are two decimal places, 0 and 4. The least of them is this one. This is the least one. So when you add them and get the final answer, which is going to be 17.04, this is not the final one. You have to approximate it to one decimal, because that's the smallest decimal, which is then going to be 17.0. You can see 4 is less than 5. So just keep the previous digit as it is. That's why I taught you rounding off. Same thing you can do for subtraction also. Always choose the least of the decimal places. But what to do when it is multiplication? Then choose the least of the significant figures. So 7.0 into 0.2. I know that the answer is going to be 1.4 meter square. Okay, 7 2s are 14 and that decimal has to be shifted. So 1.4. This one has one significant figure, and one more over here. So basically together it has two significant figures. This one, this 0 should not be counted. This has one significant figure. Choose the least significant. So 1 is the least significant figure. So the final answer should also have one significant figure. But right now this has 2. This one also, this one also. So approximately this will be 1 meter square, because 1.4 is closer to 1 than to 2. So round it off to 1 meter square. This is the right way of doing the problems. Okay. Same thing applies for division also, and any other combination of multiplication and division. Always choose the least of the significant figures. For addition subtraction is the decimal places. Moving on ahead is errors. Errors can be introduced because of many different factors. Maybe because of the manner in which it has been conducted, or maybe even the instrument itself, or maybe because of some external factors, or sometimes it is just random. Now whenever you write any value of a measured quantity, okay, and you measure something using a device and you write the value, let's say for example length, and I say it is 100 plus or minus 1 centimeter. This plus or minus 1 centimeter is the uncertainty, which is also called as the absolute error. So the degree of uncertainty is the absolute error in the measurement, because I'm not sure if it is 99.9 or 100.1, it could be anywhere between 99 to 101. Then you have relative error. So the relative error is nothing but how much is the fraction of the uncertainty. Here the uncertainty is 1 out of 100, so it is 1/100th of the reading. Percentage error is basically that relative error in this case, which is 1/100 into 100. In this case it comes out to be 1%. So the uncertainty is 1%. So that's absolute error, then that is relative error, and multiplied by 100, that's percentage error. Now what if, I want to increase this accuracy, or I want to decrease that error? So you use good devices. But no matter what you do, there is always some uncertainty, and that is because of the least count, which is the smallest value that you can measure. A normal scale has an uncertainty of 1 millimeter. Your watch has an error, no matter what you do, of 1 second. That's the least count. That's the smallest value that you can measure. Okay? Now there are some better devices for measuring length, which is vernier caliper and also micrometer screw gauge. They are really good at measuring things. They have a very good accuracy or least count, because of which you get very less relative errors or percentage errors. In case of a vernier scale, the working principle is a whole different ball game. But just remember that there are two scales. One is the main scale and one is the vernier scale. Each scale has a division. You can see this is one division of the main scale. This is one division of the vernier scale. They are not of the same length. There is a small difference between them. The difference in that length is what causes the least count. So one division of the main scale minus one division of the vernier scale, the difference is the least count. The smaller the difference, the better is the accuracy, or the better is the least count. So that's how it works for vernier caliper. For micrometer screw gauge, there is, this screw which rotates and makes sure that the object is held in between these two clips or jaws. And if you zoom in, this is how it looks. This is the main scale, or sometimes also called as the pitch scale. And you have a circular scale on which again there are divisions, also called as the circular scale. Their least count is defined as pitch divided by the number of divisions on the circular scale. If you are wondering what pitch is how much does this screw move after one rotation. So the motion, or I would say the displacement for one rotation is called as the pitch. So if I move it by 360 degrees, it moves by 0.5 millimeters. 0.5 millimeters is the pitch. If there are 50 divisions on it, then number of divisions on the circular scale is 50. So 0.5 by 50 is the least count of that particular screw gauge then. More the divisions, the better is the accuracy, because when you rotate it once, I have 50 counts or 50 steps in which I can complete that one rotation before I go from one division to the next division. So I have 50 steps in between. So more the steps, or if there are 100 steps or 150 steps, the better is the accuracy of the micrometer screw gauge. Okay. Now what if there are many readings that you take? Every time the reading comes out to be different, no matter which instrument you are using or how you are performing. And you are like, okay, what is the actual value? And what is the error in the reading? Well, whenever you get different readings, be it the same setup or be it different instruments, whatever, then you always take the average of them. So the average value is just A1 plus A2 plus A3, which are the values measured different times, divided by n number of readings. You get a better result. But each of these value will be different from this value. So there will be an error in each of these measurement given by this. Delta A1 is this value minus this value. Delta A2 will be this minus this. Now when you take the average of all these errors, you get the mean absolute error. The mean absolute error. That means it is the average. It is the average of all these errors. So it is basically delta A1 plus delta A2 plus delta AN, the whole thing divided by n. The mean absolute means modulus. So you take the modulus. How much is each value different from the average value? Take the differences, take values which are absolute. If it is negative, make it positive, take the average. That's mean absolute error. If you divide this with this value, this is the error, this is the most probable value, that will give you the relative error. This by this will give you relative. This by this into 100 will give you the percentage error. This will give you the percentage error. So the error divided by the most expected or the average value is relative, multiplied by 100 is percentage error. Now, whenever you have errors, you might have to add them or subtract them or multiply or divide them. So for example, I have some object and there is another object kept ahead of it. I want to measure their combined length. Each one might have some error. So the total error in the combined reading will be given by following rules. If it's addition or subtraction, just add their absolute errors. Example, I measure some resistance to be 12 ohms plus or minus 1 ohm, and maybe another resistance to be 5 ohms plus or minus 3 ohms. If I put them in series, then the total resistance will be, or if it is length, it will be in meters, will be given by just simple fact 12 plus 5, that's going to be 17. 0.1 plus 0.3, that's going to be 0.4, guys. In this case, it is meters. If it was ohms, I'll put ohms. Just add their absolute errors. It also is true for subtraction. So even if you do 12 minus 5, that's going to be 7. But don't subtract 0.1 and 0.3. Always add them. So 0.1 plus 0.3 is going to be 0.4. Okay, so that's how it works whenever you add or subtract the errors. Lastly, what about multiplication and division? Whenever you have to multiply and divide, always choose the positive power of each dependent quantity. Like example, z is a square. Z is dependent on a is raised to power 2. The relative error of z will be 2 times the relative error of a. No issues. I'll explain it to you using this example. Kinetic energy is half mv square. So just write it in a better way. Kinetic energy is half mass raised to 1 v raised to 2. So the relative error in A, relative error in E will be, forget the constants always, mass's power is 1 into relative error of mass plus relative error of velocity, but 2 times because the power is 2. That's all. That's the relative error in kinetic energy. Just to give you one more example, imagine density was mass by length cube. So write it in the form of powers first. So it will be m raised to 1, L raised to minus 3. So the relative error in density will be, take the power of mass, which is 1, and the relative error of mass is delta m by m. Power of length is minus 3. Always take the positive value. So plus 3 into relative error of length. Always choose the positive value, modulus value. That's how you find the relative error in any dependent quantities. So the entire PDF will be available in the Telegram channel, and you will also get updates of the future sessions. The problem solving session of the units and dimensions will be there in the playlist as well. You can watch it definitely. And if you enjoyed this video, and if you loved this video, and if you are able to revise so many different things in a very brief, concise manner, do not forget to smash the like button, guys. It would help me a lot, would motivate me to make more such videos. Thank you so much. This was Captain Shreyas. Do not forget to subscribe and do not forget to leave a comment as well. Bye bye. Hasta la vista. This was Captain Shreyas signing off.